Good afternoon, Miss, classmates, and PhD Carolina Avellaneda. This is our presentation about aerial dispersal of pathogens on the global and continental scales and its impact on plant disease. The interviewed is the Dr. Carolina Avellaneda. Next. Adaptation to host resistant. When a resistant gene is used widely, mutation to virulence in a single pathogen genotype may mean the previously resistant cultivars became susceptible across huge areas. In accordance with the prediction that unusual events may have a disproportionate effect on population dynamics. Virulent clones may initiate local epidemics, whether they are dispersed with prevailing wind, generally west to east in Europa, or against it. Virulent clones may then diversify by further mutation or by recombination with other genotypes. When GR17, that is one gene, was reported in Great Britain involving one pathogen genotype, type K isolates were found in 1997 in the first outbreak of yellow rust, that is the mean of GR17, with in Denmark, then in France and Germany in 1997 and 1998, respectively. Limited diversification of type K has occurred since in 1995. A different GR17 virulent genotype was found in England. Then in 1997, it was found elsewhere in northern Europa. At sites up to 1,700 kilometers apart. The most likely explanation for the widespread distribution of types K and O in Northwest Europe was wind dispersal of ursospores from a common source. Presumably Britain. In Denmark, the establishment of these types was in part the result of a recolonization after the local extinction of P. striformis FSP triticii for 1 year, whereas dispersal of type O to Western France we against the prevailing wind. The evolution of the virulence of Plumeria graminis, synonym of Erysifa graminis, FSP hordae, the powdery mildew pathogen, the ML13, that is the another gene. Resistant in barley followed a similar pattern. MLA13 was first used the former Czechoslovakia around 1980, then elsewhere in continental Europe, and finally in Great Britain in 1986. In 1988, when MLA 13 cultivars in Britain first had substantial levels of mildew. 3 clones of the fungus were found in widespread locations. One of these was indistinguishable from older isolates from Czechoslovakia too, and was mostly likely dispersed to Britain for continental Europe. Diverse genotypes of B. graminis, FSCP hordae, now have MLA13 virulence through further mutation and recombination. Occasionally, single-step intercontinental dispersal overcomes an effective resistance. By contrast, two genotypes of the wheat stem rust fungus, Puccinia graminis, FSP triticii, which were found in Australia 1969 and had almost certainly been wine dispersed from southern Africa, possibly Angola, didn't cause disease on any previously resident cultivar because they lacked the necessary virulences. And this is my part. My classroom, Jennifer, continue.
Okay. Well, doctor, a part of the document that caught my attention was a invasion of the new territory, where it is spoken of the two first aerial dispersion.
Jennifer, can you give the next page of the presentation, please?
Yeah. Okay, and continue. Invasion of the new territory, where it is spoken of the two forms of aerial dispersion spread diseases to places that are distant from the original source or of the inoculum. Those two forms, the more spectacular, can involve the transport of the spore over very long distances, even between continents, in a single stop, and the other is a gradual to possibly rapid expansion of the red pathogen population with a continent. Single stop invasion are red continent and likely and therefore productible. So So there are usually, though, there be unique events requiring special explanation. Rage expansion, by contrast, are generally treated as part of the normal dispersal process of the pathogens. Rage Richard, however, suggests that single stop invasion and rage expansion may be caused by the same dispersion process. It is of the difficult to determine of the original cause of a single stop pathogens invasion, but a few cases this is a good evidence that the inoculum was ever rather the carrier by the people or plants product. Most of these involve rows, which may be more likely than other disease to be aerially dispersed over very long distances because their spores are comparatively robust against environmental damage. And well, we document say they for many years there was being an invasion of the pathogens via spore they carry a disease. One continent by infect plants that are on the continent and spread those over those spores And he even said there are countries and that have acquired and disease because Korea is part of their clothes. And this is my part. Marco, have a question.
I don't have questions. Do you have questions?
Yes, I have two questions. And my question, doctor, is um, and a part on the say in the um and they say in the sport are comparatively robust again. What do you mean in this part?
So first, I want to express my gratitude with Marco and Jennifer to invite me for this short conversation about the importance on how will be the moving of different pathogens around the world. So I would like to clarify some points before to answer your question. It's so important to comprehend that all the pathogens begins to move around the globe for the migration. Migration from people, migration from animals, and also the aerial dispersal is one of the most important components for the dispersion of the plant diseases or plant pathogens. Why? Because most of the different places of origin of the different plant diseases are from Asia, from Africa, and sometimes from Europe. You can see in the map that Jennifer explained us how had been or how occurred this different migration of the pathogens. It's important to have in mind that the people have been an important participant to the dissemination of the different plant pathogens. According with your question, Jennifer, I want to aggravate that I understand that the question is about what means the different kind of the dispersion of the pathogens. Is true?
Yes.
Okay. So, for example, in the figure that you observe, the blue arrows indicate the dissemination of different pathogens by action of people or by action of the men. Why? The men can carry the different kind of pathogens in form of latent spores or different dormancy structure that the pathogen produce that carry on their luggage, they carry on their clothes, sometimes on the different storage room on the ships, the storage rooms on the planes are the most important places that have been controlled for different plant safety control points in the different countries. Why? Because are not only important the plant pathogens, thinking on diseases, thinking on fungi, thinking on bacteria, thinking on viruses. No. Also, the pests are so important because most of the pest organisms like leaf hoppers, like aphids, like beetles have the ability to be vectors of different kind of diseases, bacterial or viral diseases. It's one of the most important reasons that most of the country had been to have a big plan of security, plant security or food security in the frontier points. Thinking and talking about the blue arrows that you show us in the video. Now, I'm going to talk about the red arrows on the figure. The red arrows correspond to different pathogens that move by air currents, by the wind. The most important characteristic of these kind of pathogens is that can move in a long distance, and these kind of pathogens can develop different structures to survive and to different environmental conditions. These kind of structures that have, that in the case of the fungus call it teliospores, chlamydiospores, have the ability to resist high and low temperatures, can to resist high and low relative humidity, and have the capacity to survive under inert surfaces. That is the case that most of these kind of pathogens move by the wind once arrive to the land, to new land, like an island, like a new continent, had the opportunity to overwinter inside of the soil. And once on the soil, the overwinter structure wait for the best weather condition, for the best environmental condition to develop again, to begin to reproduce, and to begin to cause a new outbreak of the disease or a new epidemic. These are two the most important kind of the dispersion of pathogens on the world. And the most characteristic organism that develop this kind of movement around the globe are the fungus. You saw in the figure, most of the diseases are caused by fungus because fungus had the opportunity to produce these kind of structures. So important structures like latent structures or dormancy structures. Another thing is the case of homomycetes like Phytophthora infestans. Do you remember? When you begin to read about plant pathology, Phytophthora infestans is an organism that show us the importance to have controls in the different countries for the different materials, the different seed materials, vegetative materials that can move country to country in the commercial interchange of vegetal material. So I think so that I can, with this short explanation, I can clarify some points for the important aerial dispersion of the pathogens. Thank you for inviting me, guys.
Thank you, Doctora.
Thank you, Doctora. This is an important theme in the environment of our profession, because we have to know the diseases of the plants. This appeared me interesting because I was not know that spores can disperse long distance, like continental to other continental, and that's so interesting. I like this theme. And Jennifer, do you have another questions or something to add?
I have two other questions. I have, Doctor, what is the first step to know if was invasion by expansion of single stop or expansion of rake?
So, do you want to know how the pathogen move and how the pathogen invade your crop?
Yeah.
Yeah? Okay. So, to try to clarify the different sources from inoculum, you should have in mind the different crops around to to your yield. For example, you have your farm, and in your farm, you have a really big area cultivated with maize or with rice. You should have in mind that it's important to know the environment around the farm or around the field. The different crops, the neighbor crops are the most important source of inoculum to the invasion of new pathogens. Also, the different barriers, and most of the agriculture or the farmers use a big trees to try to delimitate the areas. Sometimes these kind of trees can be used like alternate hosts for most of the fungus diseases. Also, you have on mind the kind of the seeds that you use it for establish your crop. For example, thinking on rice, you should be used certificated seed, a seed that probably came from a transgenic hybrid or from a transgenic variety that have an important gene related with resistance to one disease or one pest. You should have in mind many factors: the seeds, the neighbors of your field, the kind of crops that you're planning to establish. Also, you should have in mind the water, the different irrigation systems. Sometimes most of the pathogens have been disseminated by the irrigation system. The source of the water, most of the water could be contaminated by coliforms, and also it's important depend the kind of crop that you're trying to establish. The different symptoms that you observe on the plant has been the first indicative kind of pathogen that are affecting your plant. Remember, the symptoms are the manifestation of the pathogen in the plant. For example, if you observe spots, necrosis, wilt, are some of the most important symptoms that bacterial or fungal diseases cause in your crops. You should have on mind like an integral form. You should be trying to looking for the best place to cultivate, the best seeds, the best water condition, trying to avoid the humid season, the rainy season. Sometimes most of the people prefer to cultivate during the dry season. So you should have on mind many aspects to try to clarify the source of the inoculum or try to have a safety crop.
Thank you, doctor.
Thank you for the question.
Okay, this is everything for our presentation and conversation with Dr. Carolina Avellaneda. In the name of two, we want to give you the thanks, and this is a very interesting theme. And thank you, Doctor.
Thank you guys for inviting me.